Today we're going to be working with how to complete the square, the uses for it, and kind of a simplified method of starting them. So, completing the square, there's a couple major uses for it. First one, you can always solve for zeros of a quadratic even if you can't factor. Now most of us always prefer to factor, and you're always hoping, oh, I hope I can factor, I hope I can factor. But if you can't, trust me, you can always complete the square. Even if it does get ugly, you can always complete the square. The other reason to complete the square is more when you're dealing with conics, when you're trying to find the standard form of a circle, which really helps you find the center and the radius of each circle. So throughout today, I'm going to show you a couple examples of how to complete the square for quadratics, which a lot of the students you guys have seen before. And if you've gone further in math, you'll also do it with circles within the conics section. So, solving for zeros of a quadratic. Now the standard form of an equation of a quadratic is the ax squared plus bx plus c. You guys should be used to that with the quadratic formula. That whole negative b, plus or minus, everything's about the a, the b, and the c. We're going to be using the a and the b particularly when we do completing the square. So I have a couple examples here. The first type is when a equals 1. That is the easiest type. You don't have to worry about anything. It's a 1 in front. Kind of similar to when you factor. And then I'm also going to show you where b is even. So here, I'm going to have a is 1, b is even. Now at first glance, you always want to try and factor. But when you look at it, the factors of 14, if you wanted to try and list them out, you have the 1 and the 7. Whoops, sorry about that. You have the 1 and the 14, and the 2 and the 7. Now if I try and add or subtract 1 and 14, I could either get 15 or 13. That's not my 8. And if I do 2 and 7, I can either get 9, really close to 8, or 5, but I still can't get the 8. So neither of these set up, so I can't factor. What I've told my students is that means your roots aren't going to be nice. When I say nice, a nice integer. They won't be integers, but we can still solve this by completing the square. The steps that I like to do first is take the c value and dump it over there on the right side. So I'm going to set it up as x squared minus 8x equals negative 14. So I move that number to that side. Now what I like to do is I like to set up a kind of fill in the blanks game where I'm just having a blank on this side and a blank on that side. And if you have to remember, for an equality, whatever I add over here, I have to add over on this side to keep it equal. And the way it's played is basically this. You take your b value, which is negative 8, you need to cut it in half. So half of negative 8 is negative 4. I want you to square that value. So half of negative 8 is negative 4. Negative 4 squared is 16. I want you to put that on that side. And to make it equal, put it on the far side. If I add 16 to both sides, nothing's changed. Now when I go from here, the right side's pretty easy to see. I'll keep this back in red. That equals 2. The whole idea of why I did half of negative 8 and then squared it is this right here can condense down to x minus 4 squared. Now if you're not comfortable with that, let me just on the side show you why that's true. If I say x minus 4 times x minus 4, because remember, x minus 4 squared means 2 of them. And if I want to expand this out, I can get x squared minus 4x minus 4x, and then negative 4 times negative 4 is a positive 16. If you take a look at this, those middle two terms can condense down into x squared minus 8x plus 16. That is what we were starting with right here. So the whole concept is half of b and square it, which allows you to complete the square, hence the name. Now if I go back to the solving part here, I have, I'll just write it down here so we can start again. If I'm trying to find the zeros or the roots of a quadratic, I have this right now. I want to solve for x. So I have a couple things in the way, the square and the square root. When I take the square root of both sides, I can get x minus 4 equals plus or minus the square root of 2. Now remember, I told you if you can't factor, then your roots are going to be a little bit uglier. They won't be integers. You can see that right there.
Hi, Rocky staff. If you're here for this evening's event,
I want you now to
the pizza
minus
is
the 4.
here.
Opposite of
So
that is
if you
to
want to
add
come
the
on
4.
down and grab a couple slices and enjoy the
I'm
evening
sorry
with us,
about the
we'd love
announcement
it.
up there. I'll wait for a second. So again, I'm trying to solve. So I got rid of the minus 4 by adding 4 over, and I have my 2 roots are these values. Now if you wanted to go further, you could say separately, one is that, and the other guy is that. Okay? You could go get the values actually with the decimal, which this is about 5.41, I believe. And then this one would be, x is about 2.59. And all of those mean, all this means when you're trying to find a root of a parabola or a quadratic, is it's saying at 1, 2, 3, 4, 5, at 2.59 and at 5.41, those are your roots, or your x-intercepts, or your zeros of your quadratic. Now again, to kind of take a look at this, we have this, we're trying to find the zeros. It doesn't factor, we tried that over here on this right side, which I'll box out just to remind you, this is our first attempt. Then what you do is you move the c value over, you dump it on the right side. Half of negative 8 squared is 16 on both sides. That makes it equal. Remember, this condenses down to that x minus 4 squared. Negative 14 plus 16 is a 2. When you're solving, to get rid of the square, you square root. And to get rid of the minus 4, you add it over. And that helps you find your zeros for a quadratic, even if you can't factor.